Hello, my name is Gino, and I'm going to be your CA for this episode of ChemBuddy dealing with the dual nature of light. Light is the topic that will lead us to our discussion of electromagnetic radiation and the calculations we will perform during that topic. So to understand these principles, we need to first understand light. To start, we need to understand the two descriptions of light we often hear. Light is a wave, and light is a particle. Here are some basic descriptions. A particle is anything that has mass and collides with other objects that are considered particles. A wave is anything that does not have mass and can pass through other objects. Now, improbable as it may seem, light acts both as a wave and as a particle, and this confusing fact was argued about by scientists for a long time. And instead of discussing light as we think of it coming from the sun, chemists looked at the electron to try and understand the true nature of light. We've talked about J.J. Thomson before as the man who discovered the electron, and because of his experiments, he described the electron as a particle. However, his son George Thomson described the wave-like nature of the electron. So, after a family feud between the two, it was a man named Louis de Broglie who settled the question. He determined that the electron does propagate through space as an energy wave, so to understand the atom, one must understand the behavior of electromagnetic waves. So, what are electromagnetic waves? Electromagnetic waves fall under the category of electromagnetic radiation. And electromagnetic radiation are energy waves that travel in a vacuum at approximately 3 times 10 to the 8th meters per second, the speed of light. Electromagnetic radiation includes radio waves, microwaves, infrared waves, visible light, ultraviolet waves, X-rays, and gamma rays. These components of electromagnetic radiation, or EMR, make up the electromagnetic spectrum, an arrangement of the varying degrees of radiation. Electromagnetic radiation travels through space as waves, so if we're going to talk about them, we need to understand the components of a wave. The 6 major components of a wave are its wavelength, frequency, amplitude, crest, trough, and origin. The origin is the imaginary line that bisects the wave down its center and gives us a baseline to work off. The crest of a wave is the very top of a wavelength, the part that looks a bit like the peak of a mountain or the crest of a wave. The trough of a wave is the very bottom of a wave, the part that looks like the bottom of a valley. The amplitude is the distance between the origin and the crest or trough. The wavelength of a wave is the distance between 2 crests or 2 troughs, and its typical unit is the meter. An important note on wavelength and amplitude. They will not change no matter what crest or trough you choose, as each wave maintains its shape unless its wavelength or frequency changes. Which, speaking of, the frequency is the number of complete wavelets or cycles of the wave that travel on a wave during 1 second, and its typical unit is the hertz, or 1 divided by second. Now, if you multiply wavelength by frequency for any electromagnetic wave, you will produce the speed of light, so we can use this equation for our calculations. C, the speed of light, equals nu, frequency, times lambda, wavelength. So, with our knowledge of proportions, we can see that frequency and wavelength are inversely proportional to one another, so as one increases, the other decreases. This is seen in these diagrams, for as frequency increases, wavelength decreases. Let's do a practice problem to know how to use this formula. Let's say we have a wave that has a frequency of 3.0 times 10 to the 6th hertz. Remember, that is extremely hypothetical in this situation. So if we set up our equation, C, 3.0 times 10 to the 8th meters per second, equals lambda, wavelength, times nu, frequency, 3.0 times 10 to the 6th, 1 per second. So divide both sides by frequency, let units cancel out, and you will see that wavelength equals 1 times 10 to the 2nd meters. And that is everything you need to know about the dual nature of light and electromagnetic radiation. Thank you for choosing ChemBuddy as your teaching assistant, and please come back and see more of what our channel has to offer. For my fellow CAs, Chris and Emil, we wish you the best in your studies, and hope you enjoyed this video.